This is about understanding of the, this is capacitor lab, and we are going to understand that what is the behavior of dielectric inside the capacitor. Okay, so first of all, you are about to see there are two capacitor plates given with a battery, and first we are going to calculate the capacitance across these two plates. The gap in between the plates is assumed to be the gap, you can say there is a vacuum, there is nothing in between the two plates. So let us introduce a voltmeter. In the voltmeter settings, we raise the voltage up to 1.5 volt. So now we have increased the voltage to 1.5, and as you can see the capacitor plates gain the charge. Upper one becomes positive, lower one becomes negative, and we already know the capacitance depend upon two parameters. One is area, plate area, and second is the separation. Separation, that is the gap between the two plates. So let us check the capacitance, and the capacitance comes out to be 0.89 into 10 raised to power minus 13 farad when there is air gap or vacuum in between the two plates. If you change the plate area, you are about to see on changing the plate area the capacitance is increasing. It is as per the same formula which I have written earlier, that C is equal to epsilon naught A by D. A is the area. You increase the area, the capacitance increases. You change the separation, capacitance changes accordingly. Okay. So the standard value of capacitance in the plate area of 100 mm square and the separation of 10 mm is 0.89 into 10 raised to power minus 13 farad. You may note down in your copies that the standard value for the capacitance on these particular conditions is 0.89 into 10 raised to power minus 13 farad. Okay. Next point, we are going to introduce the dielectric slab in between the capacitor plates. So here the students can see the dielectric slab on the same voltage parameter. Please look towards the board. We are considering the glass as a dielectric material, and we are going to insert this glass inside the two plates of the capacitor. Right? What will happen when we introduce the glass between the two parallel plates of the capacitor? The polarization will take place. Okay? So here the students are able to see that when we introduce the glass or a dielectric material between the two capacitor plates, students, you can see the polarization happens, and you are about to see the formation of dipoles. Towards the positive plate you have a negative charge, towards the negative plate you have a positive charge. This is the polarization of the dielectric. Now if this time you check the capacitance, what do you observe? What happens to the capacitance value? It increases. Very right. The capacitance value has been increased. So that means on introducing the dielectric between the two parallel plates of the capacitor will directly impact its capacitance value and it will be increased. Now you are having two numerical values, earlier one and this one. You take the ratio and tell me what will be the value for the dielectric constant. Dielectric constant of the paper. That is the numerical work that students can perform at their office.